Hello friends, welcome back. This is almost the final stages of our series on interacting with AI, learning AI with Python, and we have seen a lot of things. All of them are basic because I didn't want to confuse and speak like an expert, but I just wanted to get you motivated enough so that you start trying things locally and that too on your own pace. And if you have been following all the chapters, then I first of all like to thank you. And in this chapter, coming back to this session, so in this chapter we will map out our local AI application to an AWS production architecture. So all these things that you have built, you have interacted with Streamlit framework, the UI provided by that, and you have also might have used the ChatGPT, Claude, and so on in the actual setup. So how can you build something may not be as great as the commercial products, but for your team, for your organization, to solve the problems that really matter. If you want to build something like an agent, or not exactly agents, but like a chatbot or a particular application, then what sort of components that would equate from your local setup that you have seen. So everything we build locally has a production equivalent. That's one way to put it. So our local Streamlit UI could become a frontend hosted on S3, or and in combination with CloudFront with all the caching and other benefits that we get. And it could also become a containerized web app. So that could be one of the services in, for example, Kubernetes cluster. Our local fast API app could run on ECS or EKS or any other container orchestration setup, depending on the workload. So our local Llama model could be replaced with Amazon Bedrock or self-hosted model on ECS or EKS or even EC2. So there are multiple ways to, like we have multiple ways to run containers on AWS ecosystem. Same way we have multiple ways to run models. So that's one way. And our local document files could be stored in S3. So we could have a set of automations where we ingest the files, we keep it for some time, and maybe we have some sort of intelligent tiering so that we save cost over there. So that's again a different process. And our local metadata could be stored in DynamoDB or Postgres. Then when it comes to local vector search, that could be leveraged. This facility could be leveraged using OpenSearch serverless, but the cost has to be monitored, or beforehand, maybe during POCs should be monitored closely. We could also use Aurora PostgreSQL with PG vector or any other vector database. Then the logs that we were looking at in the previous video, we could use a more professional approach like CloudWatch for logging, and there maybe use lower retention policy for lower environments like test or dev environments. For production, we could have a nice longer period. And we used a lot of environment files all along, and when we start interacting with outside world or different services, we have tokens, access keys. So for that we could leverage secrets manager, or keep something environment variables like the URLs and so on in SSL parameter store. So like you see now how this is evolving from a local setup to all the like to like services on AWS. And any DevOps engineer who has worked closely with AWS services and created normal enterprise applications or hosting applications using any infrastructure as code solution would be easily able to figure out what different services I need and how to all glue them together, what sort of CI/CD I need for this. So obviously now coming to IAM, which will be joining all these things together. So we would obviously follow least privilege permissions, And the networking should be designed with VPCs, obviously private subnet, and all the tightening around security groups, endpoints with least privilege. And if this becomes a serious application, we need a reliable way to do deployments multiple times, release and deployments multiple times. This could be GitHub Actions, using Docker image, pushing it to ECR, and then deploying infrastructure with, for example, Terraform or OpenTofu. So we have various components. We have how to mechanism how to do CI/CD. Then when everything is live, and obviously we need monitoring for AI systems. Include not just, it shouldn't be like traditional CPU and memory. We should also track latency, failed request, model errors, token usage, retrieval quality, and user feedback. So these are some key components, because AI is a different ball game. We cannot treat them as a traditional application. So this could be a nice way to get your hands dirty with some tools like Langsmith, which is I can also share you my previous blog post where I talk about how we monitor token usage and other things using Langsmith. So it's this whole chapter is not about writing code. It's about understanding how the local learning that we have done in a local setup. This was because we were doing POCs, experimentation with Python, and we were not trying to burn our credits. So how, when we are mature enough, we can move to the next stage of our productionizing the whole solution. So it could be something like this. You could go with a approach something like this: local first, so everything is looking good. Then you could start drawing the plans on how to take it to production. And once you have success on the maybe the lower environment, then you could transform everything into infrastructure as code, so that the whole setup would be repeatable and error free. So yeah, and then obviously the security is a major topic. So all applications often process sensitive documents, user questions. So we need to think about access control, data retention, encryption, prompt injection, model output handling, and compliance. So when all these things come together, you know that you are getting close to building production grade applications. So that's I would say a foundation of AI engineering with Python, because any YouTube tutorial or playlist that you pick up, any random one, I challenge you, everybody talks about the importance of Python as a language, the importance it has in the whole ecosystem, whether it is deep learning or machine learning or even data engineering. So it is a multifaceted application programming language, and it has a lot of contributors, a lot of libraries, which makes everything easier. So if you found this course useful, you can keep going ahead by improving the project, adding some test cases, adding real vector databases, deploying it to AWS, and turning it into your own portfolio project. So I would like to thank you for following along, and this was an AI engineering for DevOps engineers. So upgrading from the usual enterprise application to start building AI application. So if you want to keep going, I would recommend or suggest you to clone the repo, run examples, change the prompts, try different local models, and then try to add a vector database and deploy a different version, the whole into AWS. So that could be a nice way to learn. Thanks for watching, and I'll see you in the next video. Until then, have a nice day. Take care. Bye bye.